Today we are going to start semester 2, chapter number 9, mechanical properties of solids. So first of all, we start from the introduction. And in introduction, we have learned the difference between the rigid body and the solid body. Okay. So a rigid body generally means a hard solid object having a definite shape and size. A system of particles in which interparticle distance remains invariant is known as rigid body. Means in the interparticle distance are constant, remaining constant. Means invariant is known as the rigid body. A solid body can be deformed, whereas the rigid body cannot be deformed. A rigid body is an ideal concept, hence it is difficult to obtain it in practice. So in reality, the solid bodies can be stretched, compressed and bent, mean it can be deformed, hence solid bodies are not perfectly rigid. Okay. So here we clearly understand that the rigid body, the perfectly rigid body is not possible. It is just ideal concept, just as ideal gas is a ideal concept in chemistry. That's why here is rigid body is the ideal concept in physics. That's why. Okay. So and what is the plastic of the body? Now here we learn about the another thing, that is elasticity, and what is the plastic body and plasticity. So here the property of a body by virtue of which it tends to regain its original size and shape when applied force is removed is known as elasticity, and the deformation caused is known as the elastic deformation. If you apply the force to lump of a putty or mud, they have no gross tendency to regain its their previous shape, then get permanently deformed. Such substance is called plastic, and this property is called plasticity. So here we clearly understand the difference between the elasticity and plasticity. Okay, those substances have permanently the deform. Those substances are called the plasticity. Okay, and another substance that is regain its original shape when applied force is removed, then it's called the elasticity. Okay, so putty and mud are the close to the ideal plastics. Now we learn about the stress. So first of all, what is the stress? When the force are applied on a body in such a manner that the body is still in static equilibrium, it is deformed to a small or large extent. So the deformation depending upon the nature of the material of the body and the magnitude of the deforming force. So the deformation may not be noticeable visually in many materials, but it is there when a body is subjected to the deforming force. A restoring force is developed in the body. So the restoring force is equal to the magnitude but the opposite in the direction and applied force. So the restoring force per unit area is known as the stress. So here we can define the stress from this definition, that is the restoring force per unit area is called the stress. Okay, so the magnitude of the stress, that is F by A, and the unit of SI unit of the stress, that is the Newton per meter square, because here F is measured in Newton and area is measured in meter square. So the unit of the SI unit of the SI unit of the stress, that is the Newton per meter square, and another that is the Pascal, and the dimensional formula of this stress, that is the M1 L raised to minus 1 T raised to minus 2. How it comes? Let us see. So F, from the Newton second law we can write F is equal to MA, and area is as it is, so it is measured in meter square. So we write the unit of this area, that is the meter square, and mass is measured in kilogram. Okay, and acceleration measured in meter per second square. So second square I write in denominator side. So here meter, 1 meter is cancelled out. So clearly here we can write kg divided by meter into second square. So here we can write the M1 L raised to minus 1 and T raised to minus 2, because length and time is in denominator side. That's why. Okay. So this is the MCQ question, means a short answer question. Newton per meter square, SI unit of the stress, and the dimensional formula of the stress. So please write down these things. I can give a 1 minute. You can write these things. First of all, you can write this formula, then SI unit, then dimensional formula. All are the MCQ type question. Please write down this. Learn about the strain. So what is strain? If the body under the external force, its dimension change by 3 ways: in length, in volume, in shape. So in fractional change in the dimension of the body is known as strain. A fractional change in the dimension of the body is known as strain. Means यहाँ पे small changes होगा, okay, dimension में, object के dimension में small changes होगा, उसको क्या बोलेंगे हम? Strain. So the longitudinal strain, that is the deforming force to produce a fractional change in the length, is known as the longitudinal strain. If the original length is L of the body and F is the deforming force, it changes length, that is delta L, then the longitudinal strain, that is the delta L by L. Okay. We talk about the tangential or shearing stress or strain. In the figure, if the two equal and opposite deforming forces are applied to the cross-sectional area of the cylinder, and there is a relative displacement between the opposite phases of the cylinder. Okay. See this. This is we apply. Here we apply the deforming force. Then the shape of this cylinder will be changed. Okay. So the restoring force per unit area developed due to the applied tangential force is known as the tangential shear or shearing stress. As a result, applied to a tangential force, there is a relative displacement delta x between the opposite phases of the cylinder as shown in figure. So we can see from this figure, that is the deformation in delta x, change in the breadth, okay, stress. So as a result of the applied tangential force, there is a relative displacement delta x between the opposite phases of the cylinder as shown in figure. Due to this, the strain also produced is known as shearing strain. This is the shearing strain, and this is defined as the ratio of the relative displacement of the faces of the length of the cylinder, that is delta x by L. Okay. Now we learn about the stress strain curve for a metal. It is very important here in this chapter. Okay. So we learn these things. Yeah. So a stress strain curve for metal is shown in figure. So the stress strain curve for metal is shown in figure. For a graph, we can see that the region OA, the curve is linear. In this region, Hooke's law are obeyed. Okay. The region between O and A, the curve is linear. See this. So see this curve OA is linear. So in this region, Hooke's law is obeyed, and the body regains its original dimension when applied force is removed. In this region, the solid behaves as an elastic body, because here the fractional, here what will happen? Small deformation are occurs. That's why the strain is proportional to the strain. So Hooke's law is obeyed in this region between O and A point. Okay. Elastic behavior. Okay. In the region of A to B, the stress and strain are not proportional. So the body still remains in the region of A to B. The stress and strain are not proportional. The stress and strain are not proportional. The body still returns to its original dimension when the load is removed. So the point B in the curve is known as yield point. It is also known as elastic limit. Okay. It is also known as elastic limit. And corresponding stress is known as yield strength of the material. So the point B जो है उसको हम क्या बोलेंगे? That is sigma y, yield strength. Okay. And point B is nothing but it is the yield point, also known as it is the yield point. Load is increased further. The point B stress is developed exceed yield strength, and the strain is increased rapidly. The portion of curve B to D, when the load is removed and say at some point C, B and D, the body does not regain its original dimension. See this from the graph. The body is not regain its original dimension. It regains not its original shape, that is on point B. So the portion of the curve B to D shows this: when the load is removed, say some point C between B and D, the body does not regain its original dimension. In the state even when the stress is 0, the strain is not 0. Okay. So the material is said to have a permanent set. The deformation is said to be a plastic deformation. And the D on the curve is the ultimate tensile strength of the material. Beyond this point, additional strain is produced even by the reduced applied force, and the fracture occurs at point E. Okay. So from the figure we can see clearly the plastic behavior, that is between the point C and D. At point D, that is the sigma U. So sigma U is nothing but it is the tensile strength. Okay. And point E is, that is the fracture point. When we apply more force, then body doesn't regain its original state. Okay. So it become break. It will become break. And that break point, that breaking point, that is the fracture point. So if the ultimate strength of the fracture point D and E are close, and the material is said to be the brittle. Okay. Material is said to be the brittle. If they are apart, the material is said to be ductile. So this is how we can define this stress strain curve and all the points. These all bullet points are very important in examination.